What I want to do in this video is use all of our powers, all of our knowledge of trig functions and trig identities in order to figure out, given all the information that we have here, in order to figure out the length of this yellow line, this point, this line that, or the segment that goes from here to here. And I encourage you to pause the video and think about it before I work through it. So I'm assuming you've had a go at it. And in doing that, you might have realized that, okay, this line, that's one of the sides of this right triangle that I have right over here. And we're given this alpha and beta, but if we consider the combined angle, alpha plus beta, then this side right over here, we can just take out our traditional trig functions. So our SOHCAHTOA definition of the basic trig functions. And we know that sine is opposite over hypotenuse. So if we're considering alpha plus beta, this angle right over here, opposite over hypotenuse, that's going to be this length over the hypotenuse, which is 1. So sine of alpha plus beta is going to be this length right over here. So that seems interesting. So let me write that down. Sine of alpha plus beta. Sine of alpha plus beta is essentially what we're looking for. Sine of alpha plus beta is this length right over here. Sine of alpha plus beta, it's equal to the opposite side, that, over the hypotenuse. Well, the hypotenuse is just going to be equal to 1, so it's equal to this side. So another way of phrasing the exact same problem that we first tried to tackle is how do we figure out the sine of alpha plus beta? And if you're familiar with your trig identities, something might be jumping out at you that, hey, we know a different way of expressing sine of alpha plus beta. We know that this thing is the same thing as, the sine of alpha plus, or sine of alpha times the cosine of beta plus the other way around. The cosine of alpha plus, or times the sine of beta, times the sine of beta. Let me draw a line here so we don't get confused. So if we're trying to figure this out, and we know that this can be re-expressed this way, it all boils down to, can we figure out what sine of alpha is, cosine of beta, cosine of alpha, and sine of beta? And when you look at this, you see that you actually can figure those things out. So let's do that. Sine of alpha, I'll write it over here. Sine of alpha is equal to, this is alpha. Sine is opposite over hypotenuse. So it's 0.5 over 1. So this is equal to 0.5. So that is 0.5. Cosine of beta, this is beta. Cosine is adjacent over hypotenuse. So this is beta. The adjacent side is 0.6 over the hypotenuse of 1. So it's 0.6. 0.6. Cosine of alpha, adjacent over hypotenuse. It's square root of 3 over 2 over 1. So that's just square root of 3 over 2. So this is just square root of 3 over 2. And then finally, sine of beta, opposite over hypotenuse is 0.8. This is 0.8. And actually, let me write that as, I'm going to write that as 4/5, just so that that's the same thing as 0.8, just because I think it's going to make it a little bit easier for me to simplify right over here. So what is all of this equal to? Well, this is going to be equal to 0.5 times 0.6. This part right over here is 0.3. 0.3. And square root of 3 over 2 times 4/5. Well, let's just multiply them. Well, 4 divided by 2 is 2. So it's 2 square roots of 3 over 5. So this is equal to, or so plus 2 square roots of 3 over 5. So this is essentially our answer. I feel a little uncomfortable having it in these two different formats where I have a fraction here and I have a decimal here. So let me just write the whole thing as a rational expression. So 0.3 is obviously the same thing as 3/10. 3/10. So that's the same thing as 3 over 10 plus, now this, if I want to write it over 10, this is the same thing as 4 square roots of 3 over 10. And of course, if we add these two, we are going to get 3 plus 4 square roots of 3 plus 4 square roots of 3, all of that over 10. And we are done.